those who are here will jump ahead of competitors because you will design better queries and will take advantage of new features in the optimizer for MySQL 8. The optimizer is the brain of MySQL, and it listens to you, it talks to you, it can read, and it does a lot of things. It eats data, digests it, and it does things, and it never sleeps. We will be talking about new features introduced in MySQL 8, as well as, in particular, new features introduced in the last year since the improvements were presented at last Open World last year. And let's start with a little bit of marketing. So in MySQL 8, we are striving to be more and more standard. And we receive some acknowledgement. If you happen to read this very interesting blog, you will find very good comparisons between more trendy databases, and you will find very good tables with compatibility against different features, standards, and so on. And we are very green this year because we managed to introduce some very, very important improvements and ways to design queries. MySQL was a bad boy before because it was slow on standards. And it is also true that most designers still use a very standard relational SQL, while now we are moving to different patterns, as we see, with CDE and Windows function, will allow the database to perform some computations for us that we would otherwise do in the application. So we gain a lot of speed and ease of design. And we receive very good feedback, and this is very new, actually. I think it was tweeted yesterday, so I updated my slides right away. And yeah, you're reading also hash joins, and we already presented hash joins in the keynote. I won't be adding any further information. So we'll start with a very quick recap of what we introduced in MySQL 8, just for you to be aware. I will be fast on this because I want to jump on the features introduced from 8.0.14 to 8.0.17, plus a dive into 8.0.18. So this is basically what we added. It's just a quick summary. You can tweet everything you will read today here, but we'll also be able to download the slides from Open World portal. Every slide can be downloaded for your reference. So apart from being more Unicode compatible with the latest Unicode 9, with more languages and the UTF-MB4 new char set, and we did it taking into account performance as well. And introducing new features about geography support and more than 5,000 spatial reference systems and new types and the capability to hash coordinates, so to be able to export, import, index, and so on, and treat spatial coordinates as JSON. Very interesting features like skip log and no wait. So imagine you want to find the seats and you are choosing the seats in a theater or on a plane and somebody else is trying to book those seats, and this means that those corresponding rows will be locked, so you won't even see at all, because our select will skip those locked seats. And you will have a real picture of what you can book as a seat. Or you may want to provoke the failure if you find that those range of seats are already being looked by another user. So this indeed is very useful and adds a lot of simplicity to your queries and design of the application. And we added JSON. So we added JSON data type, a real lot of JSON function. I've added here a link to our docs because there's a real lot of function to manage, transform, join, merge JSON data types. And we can bridge from a JSON to a relational table. So we can simply transform it and import as a SQL table. What else? We've added some index extensions. We've added the invisible index. You want to test if removing such an index is okay. Maybe you have a redundant index and you want to remove an index and make sure in your benchmarks and testing suites everything is okay. You can make it invisible. Removing and adding an index comes at it has an overhead. So you can first of all make it invisible and see how it goes. You can add it later. And if you're happy with invisibility, you can remove, you can drop. Having indexes that are no use, that are redundant, is always expensive. So you remove an extra cost you're not needing. We added the capability to create descending indexes. The syntax has not changed, really. We had the same syntax in 5.7 as well, but it was not considered at all. So it was silent. It was cheating a bit. It was added not to make your queries fail. But usually indexes are created in ascending order. That is, that the B tree is ordered in ascending order. You can scan it backwards, but it has a cost higher. So it's quicker forward and slower backward. So you can create both. If you want to absolutely be sure you are as fast as you could be with MySQL 8, you can create the bit tree ordered in both senses. And skip scan, when we cannot use a composite index, so a composite index is an index on more columns, A, B, C, and where the filter is not on the leftmost column, but on the middle, on the right column, and so on. Before this optimization, we couldn't use at all the composite index. Composite index can be used if you have a composite on A, B, C. You can use it on A or B, or A, B, C. Now you can also use an index on B. It's not as efficient as having a single index on B, but we reduce a lot of scans, and you do smaller scans, and it is more efficient. The algorithm is not exactly like this. It's just a quick summary, but in our docs, we'll find the whole description of the algorithm chosen to implement skip scan, and that's thanks Facebook for this interesting contribution. All right. Cost model, and we improved our cost model. Cost model is based on constants, and if you are a very, very skilled DBA, but you must be a skilled one, and you must have a really good testing of your workload, so you can make sure that upon a minimal change to a constants considered by the cost model, you receive an improvement in performance. So this can be tuned, it has been improved, and it takes into account here there's regarding data in memory or from disk, you can tune it also further constant, but the optimizer can choose an execution plan depending on if the data is already buffered in the buffer pool or not. Because sometimes when we do, as an example, range scans, we may be faster to read from disk because reads from disk are sequential. On rotative disks are sequential. Then maybe faster than scanning in memory. And the optimizer now is capable to distinguish where is your data, either in the buffer pool or on disk, and take a decision. And we added the histogram. There was a session on histograms during this open world. And it gives you more power because histograms is sampling tables, indexes, distributions, and understand how to best use execution plans, knowing the distribution of value and so on. It creates statistics and so on. All right. And hints. We can do now things per query, and we can add a hint to say, I want this query to perform like this. So not only I can configure global behavior for my MySQL 8, but I can say, all right, I have sort buffer size, it's global, it's like this. But I know that this query will need such a sort buffer size, so I allow the query to be run with a bigger buffer size. And we can say if we want to merge or not merge an index. So if this is about index merging. It's an optimization. We already had the setting, but it was settable through optimizer switch, so globally. And now we can also configure it per single query. Same for join orders. So we can get rid of straight join keyword, I guess. And this is yet another improvement that is whether we want CTEs, derived tables and views, to be merged to the other query or materialized. Such tables, CTEs, derived and views, are materialized. That means that a table is created and can be also indexed as a temporary. So the query is executed by making use of this temporary table, which materializes those views, derived tables, and CTEs. And the optimizer may choose to add an index as well. But there are, let's say, rules to determine if it's better a merge or not. Merge, it means that it won't be materialized and that it will be rewritten. It's let's say it's derived. It's a subquery, and it's rewritten, so it is merged to the outer query. I know it sounds like difficult to explain. I didn't put here examples, but there are on our docs. So remember to check tables merge or materialization. It's a typical optimization. And there may be cases where, and I found at least one working in support, where the optimizer doesn't choose the right path. Possibly, and most likely, because statistics samples are not enough. Most likely. Sometimes we increase the number of samples the optimizer use to sample data, and understand what data distribution it has. It is expensive as well. It must be recurrent. MySQL 8, whatever MySQL, I guess, auto-updates statistics, and you can force, it's the analyze table. And maybe you don't have, maybe you run obsolete more often than you would, obsolete in the terms of, the meaning of statistics. So with this, you force to choose a path, and you forget about policies considered by the optimizer on whether materializing or not. CTEs. All right. I was designing an application, and it was a hierarchical application. I was writing an editor of texts to structure texts as a tree. And I wanted to do searches. And with MySQL, I couldn't. So I used, in my application, SQLite 3. It's a very simple database. It's a library. You link to it was a C++ application. And with that, you can traverse with CTE as recursive. You can traverse a hierarchy. So it's recursive, and it gives you all the nodes of your tree, all the leaves. So I had all the files in my hierarchical tree, and I could search texts within those files. This is the recursive version, and now MySQL 8 it has as well. It's a standard, and in MySQL 8 we have it. So I think it's one of the biggest highlights. What is a CTE? It's a derived table. The derived table is a subquery. The derived table is after the from. So it's a subquery. And you call it derived table when it's after the from. If it's not in the from, it's not derived. So CTE is a subquery that is at the beginning of the query, at the very beginning, before the select. You call it with derived as, and there you put your subquery. And then what happens? You can reuse it everywhere you want in your query that is coming. So it's an alternative for readability, because you find it, the first thing you find is your subquery, and multiple CTEs you can put on top of your queries. So you put things on the desk. These are the subqueries I will be using, and then you write your query. So this is readable. You can reference multiple times. And it increases performance, obviously, because if you need it 2 times, you don't have to recalculate it every time. So it simplifies the syntax of your query, and it gives more performance. And this is what I like particularly, because you can really make things easy in MySQL. You can traverse a hierarchy, but you do it in the application. It overcomplicates your application. This makes it everything easier. All right. And window function. Window function coming from, CTE were coming from SQL 99. So we are like 20 years later. And SQLite as a database, I don't know in which years, but I used some years ago. And window function from 2003. So it's an aggregation function, and permits to do custom aggregation following rules you want to follow. So this is a very simple one. It accesses rows in the vicinity of the current row. So here, I think it's a copy-paste from somewhere in the documentation. So we'll find several examples there. We'll find the total salary per department. It's repeated because it works like this. So DAG from depth ID 10, okay, Ed, poor DAG. Ed earns 10,000, and his department is paying this pay sheets. And this is the basic windowing function. Then you have frames, and you can do a lot of stuff. I won't spend time here, but be aware that things that you were doing, aggregations that you were doing in your application, now you do them in the MySQL. So this makes a bit everything change, because when you were talking about MySQL performance in returning data, now the concept of performance of your service, web application, or whatever, it's not just the DB. It's also the time you save from the application, because you delegate those computations to the database, which is certainly faster. So the performance of your MySQL-based service now, it's the performance of the overall application plus MySQL, because you can remove overheads in your application, get less data to process on your application, and just delegate MySQL to do things for you, because MySQL is scanning tables anyway. So let's add a little job to do things for me. And this is very, very powerful. And starting from here, we begin talking about 8.0.14 till 8.0.17. It's the current GA. So I will just quickly show what we've added in the last year. It's 14, 15, 16, 17. It's 4 releases, plus a quick dive on the 0.18. In our effort to follow standards, we've added, we've improved the GIS functions to calculate distance between spatial points. And now we can do passing the unit. The standard is here. The standard is pretty huge. I downloaded, out of curiosity, I think it was 130 pages, so I to the trash bin immediately. And in parallel, we can calculate also ST length, and we pass the unit we need. And we've added all the units of measure in information schema, so you can consult them. The default is meter, and the conversion factor is 1. There's plenty of units. Have a look when you're at home. All right. More standard. Okay, this is yet another very interesting one, because it now permits something that was illegal in SQL 92. When you listen to SQL 92, it's the standard SQL that you're using, most likely. It's the standard SQL. So it is a standard from how many years? 27 years ago. So we're working, our application are working with SQL standard from 27 years ago. So there's a lot of new things that you can exploit right now. And so this is a feature from SQL 99, and it allows you, in a query, to, if in a from condition you have a table and a subquery, then you can reference in the subquery, in the derived table actually, you can refer to the other previous tables on the left side, on the left side. So here in red, in this subquery, I'm using a reference to salesperson that is on the left, not on the right. Otherwise, it gets complicated and it's a mess. So for simplicity, we can only refer to tables coming before. And what's lateral? What's lateral? Lateral is a way to do a for each loop within the from. Because, as you notice, for a salesperson, for every salesperson, I'm doing a computation. I'm creating a derived table whose values are calculated on the salesperson again. So it's like, for those of you who code stuff, it's like a for, and for each there's another for inside. So it's a nested for. Okay? So this is possible when you have a nested for, you have for E, and nested for J. In the second loop, you see the E, right? So this is the same concept, but extended to SQL. It's for each. If you don't use the lateral keyword, you will get an error. So I removed lateral, and you cannot use the reference anymore. So this is powerful. So according to me, up to now, we've seen CTEs, Windows functions, and lateral. And I want to bring home these three ideas for now. Let's see what else we can bring home. All right, this is not so satisfying as a lateral, possibly, but it's yet another limitation that we have removed, because now we can have, this has been allowed by Standart since '92. So we were old, very old again on this. With lateral, references are to tables in the same from, right? Now the limitation is lifted for tables outer to that clause. So you see, this is the from. I'm creating a reference to this one that is in the not the same from, but it's outside. Okay. So I don't have now a very clear example. So lateral is for each. With the first table in the from, you can then, in the following derived, you can like iterate. I don't have a clear example here, but our docs have. This is a new standard, SQL 2016. So we've added this cast. So it's possible to now cast as float and as double explicitly. We've added, okay, well, this is boring. We've added collations and Chinese collations and a binary collation for UTF-8 and before. I won't stop here too much. Optimizations, okay. This is interesting because it can save you a lot of rows to be read and scanned by the optimizer. And it's about the semijoin. And semijoin is not something that you hear too often, and but it has not a syntax called semijoin. I think I've read, pardon my ignorance, but I think I've read that there is some database with semijoin syntax. Nobody can confirm. Maybe I have invented it, but but I think I read it. All right, what's a semijoin? The semijoin is an optimization that we will see right now with an example because it's easier. And if you understand the meaning of your query and you rewrite it using in or exists, then the optimizer will use a semijoin. So you cannot declare explicitly, I want a semijoin, but you can use in or exists and their respective negations to have the semijoin, which is a very fast scan on what you're interested in. So, first rule of a PowerPoint presentation, never add more than 3 bullets. I'm sorry, but I had to put one example here. So, I want to list all the classes that have students enrolled. I can do this with a select. Select class, number, class name, from class, and I join with roster, and then I get all the combinations. I have overlapping classes, because I get a Cartesian product, basically. So I get all combination, and I have the classes names repeated a lot of times. It's too much. I can use a distinct, right? So I get only one. But I've already fetched too many combinations. So it's a loss of time. So what can we do? It is possible to use this join. Select class number and name from class where class number is in, so we have one table here, just class, where class number is in, and we reselect from roster, that is the other table we were joining to understand if students are enrolled. So when the optimizer reads this, knows that it must do a semijoin. So as soon as one result is found, it stops and go back. So as soon as one result is found, so we don't have to do all the Cartesian product to give all the combinations and then do a distinct. So this is much more efficient, right? And this is powerful, I think. But you must use this syntax. And this feature, because we had this first just for the in, and then, so this is the power of this feature actually, in optimizations extended to exists, semijoin. So this strategy, the same, can be employed with exist subqueries. So by transforming an exist subquery that appears at the top level of a where, etc., etc., etc. So this is basically rewritten, and then with the in, it's the same. Logically, this is the same construct. And with the in, it's the optimization, semijoin optimization is applied. And in the symmetric way, we have the anti-semijoin. That is, when I will make it short because I'm running out of time. When I want to make sure that there is no element on the other side, on the other class, there is no match, as soon as I find one, I stop everything and return. So this is the negation. And again, this is an anti-semijoin. So the syntaxes are not in and not exist. Several examples in our documentation. JSON. I think that JSON has joined. Well, we are almost done, and I think that we are on time. Yeah, great. Okay, we discussed about JSON previously, and we added now schema validation. MySQL 8 don't remember which version introduced check constraint. So you can create a table, create table, blah, 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 check constraint, and you can say what constraint you want on a field. So, example, an int to be lower than, or something like that. Now you can create a table with a JSON schema validation. So when you provision a record with a JSON, if the JSON is not validating against its schema, it is rejected. But not only. You can also use two functions. If you are not using check constraints for a table, you can also validate it and then push it to the table. Or do whatever you want, because you can check schema valid, and there's also this function JSON schema validation report, which is more complete and gives more information, etc. So if you have such a JSON document, then you can write a schema like this. So you want coordinates to be within a range. And you validate it. And here in this example, you get a failure because we have 310 as longitude, and it's beyond our constraint. So the value returned by the JSON schema validation report is that the requirement maximum is not good. And this is a nice feature if you are using JSON, indeed. So when you have arrays, you can index values in the arrays. So example, in our JSON here, we have user ID, zip code, because Bob has got 2 houses. And when you search for a zip code by using one of those JSON functions, we have plenty of them, that is member of, JSON contains, or overlaps, and so on. So now we can use an index within the JSON field. And we call them array indexes, or somebody else call them multi-valued indexes, and so on. So here it is. So you do a select star from customers where the zip code, this zip code, is member of the array of zip codes. So our optimizer tells us so, that we're using the right index. So this is quite powerful. So if you're using JSON, I think schema validation and indexing arrays is nice to have and to use. And all right, we have also window functions for a JSON array. It's same as using the syntax as it was used with window function, with over. And we can use it over JSON data types, and so on. I won't stay here. I'll go to hash joins. All right. When we have joins that are not indexed, we do nested loops. What's a nested loops? It's a for table, and then nested another for the other table to do the join, because they are not indexed and we don't have any chance. So MySQL uses this algorithm, the NL, nested loop. BNL, it's not nothing strange, it's just the batched, because we can use the buffer join to do batches, so read batches of stuff, put in memory in the first join, and then when we are computing the second join, we can use data in memory and not reread every time. So we are saving data in memory. That's why unindexed joins make use of buffer joins. This is not good, this is bad, this is memory consuming, and especially when you're under high concurrency, and also CPU, because when you allocate, and if you have 32 megas of buffer join and an unindexed join, you allocate, and your CPU jumps up, obviously. So hash join is the way to do things intelligently, and it's an optimization that is chosen by MySQL when it finds that there are joins unindexed. So you can find a lot of literature online, a very nice YouTube video when you search for hash joins with the mechanism. It's explained, but it's a two-phase mechanism that is a preparation and matching. The preparation, hash values in the first table, builds a hash map. And for those of you who develop, know that hash map is very fast, usually fast. And we can suggest MySQL to force hash join or not, because we added hints. By default, it replaces BNL by default. So in MySQL 8.0.18, retest your workload because you may find nice surprises. And I am not sharing benchmarks, but they were very good. Very good. It's not maybe not the typical situation to have an indexed join and using a BNL, because you have already very good design. That's not what I see in support. So ideally, it's OK, but in reality, we have different things. So yet another simplicity for the user. And remember then, when things are simple, it's that there's a lot of complexity below. So we add the complexity to the optimizer to be more intelligent, to make things simpler from the application point of view. And last but not least, we already presented in the keynote, same as the hash join, we're adding one more tool to understand what you're doing. So the explain analyze will, it's not just an explain. The explain query does not execute the query, and it gives you an estimation of execution paths. The explain analyze, yes, it executes the query, but gives you also partial execution times for the different phases. So you can very well understand what is slow in your query. And this is powerful. Not in the, for now, for the release coming, not for the plain explain, but only for the tree output, okay? Maybe in the future we will, I don't know plans, but I guess that we will be also on the plain one. And before I'm kicked out of the room, I called it Miscellaneous, which I didn't know how to pronounce it, Miscellaneous. Next time I use more. And this is a list of miscellaneous, but in reality, it's deprecation and time's up. So if deprecations sounds bad, remember that it's for good, because everything you read here and when you download, read here, it's standard. So we removed non-standard thing like this. If you code C, this is C. So you were using C in your SQL. Now you cannot do it. So be aware. After deprecation, there is obsolescence. So better to download MySQL 8.08, adapt, and remember that everything is possible with MySQL. bring this home, please. CTs, window function, hash joins, and explain analyze. Thank you.